Hi friends, welcome back. We're talking today lesson 64, Saxon Algebra 1. It is the Orange Book 3rd edition, Domain and Additive Property Inequality. Before we get started, just a quick reminder here. I sketched out some quick notes. We have two types of, when we're talking about numbers, we're talking about either real or complex numbers. You won't get to complex numbers until Algebra 2. So right now we're talking about real numbers. Now, within those real numbers, we have two types. We have rational numbers and irrational numbers. Remember, the root word of rational, let's see if I can quickly find my highlighter here. The root word of rational is ratio. Ratio. So what that tells us is rational numbers are, are numbers that can be written as a ratio. And remember, ratio, just a fraction. So things that can be written as a fraction, 1 over 5, 37 over 22, anything that can be written as a fraction is a rational number. Irrational numbers are, for right now, the most familiar you'll be with are pi, because that is 3.1415, blah, blah, blah. It goes on. It never ends. It's a decimal that never ends, and it doesn't repeat. If a decimal doesn't end, it can be rational as long as it repeats. For example, 0.3 with a line over it, that's a rational number, which is 1 over 3. So this is all relevant because, it can be turned into a fraction, therefore it's a rational number. The other ones for irrational are non-perfect square roots. So 7, square root of 11, things like that. Those would be irrational numbers. So within our rational numbers, we have counting, whole, and integers. So this is just a quick refresh on that. Counting numbers, things we use to count, 1, 2, 3, 4, whole numbers, 0 plus our counting numbers. Integers are 0 plus our counting numbers and their opposites. So -2, -3, -4, so on and so forth. So rational numbers are all of these numbers plus any decimals or any fractions, any decimals that are terminating or that repeat. Okay, so why is this important? Well, when we go to talk about domain, remember, domain is your x, which is your input. So eggs are 10 cents. For example, eggs are 10 cents. We're going to put in how many eggs we're getting, and we're going to get out our total cost. So our input, aka our x, aka our domain, that's what we're putting in. So the things that we're putting in, so for example, if we buy 10 eggs, that would be 10 times 10 cents, that would be $1, right? So we're going to take 10 cents and we're going to multiply it by x, which is the number of eggs that we're buying. And we're getting out y, which is total cost. Okay, so this is our input, this is our output. Remember, input is our x, which is domain, output is y, which is range. Now, the reason I say this is because our domain can be something, this can be restricted. Our domain in this case is any whole number. You can't buy an egg and a half, right? Unless you're cracking the egg, and I don't know how you would do that. Well, I know how you'd crack an egg, but I don't know how you'd split that egg equally into half. You can't do like 3 2/3 of an egg. So in this case, our domain is restricted only to whole numbers that are, whole numbers, but that are positive whole numbers. So can we do 0 eggs? Yeah, we could. That's kind of a questionable one. But we can't do -1 egg. We can't do a negative egg. So our restriction on our domain here is positive whole numbers, either whole numbers or counting numbers, right? Going back to my little list. Okay, so I gave myself all this room and then I didn't use any of it. I don't know what I was thinking. So here we go. Remember, here's a good one. These two symbols, the way to tell the difference is if it looks like an L, it's less than. See how that kind of looks like an L? That means it's less than. And then this guy is greater than. So when I look at this one, I see that this does not look like an L, so it's greater than. So x is greater than 2. The domain is all real numbers. So this is written correctly, meaning the x is on the left-hand side. If it was not on the left-hand side, you'd have to rewrite that. And what I mean by that is if it was like this, 3 is less than x. This is not correct. I mean, it is technically, but you want to get in the habit of rewriting it. X is greater than 3. Notice when I rewrite it, I'm also flipping my sign. The reason I say that is if it's written correctly, it helps with your arrow on drawing. So x is 2. So I'm going to put 2 right in the middle here. And I'm going to say 3, 4, let's just do another one, 5, and then this is 1, 0, -1. And it says all real numbers. So remember, real numbers includes rational and irrational numbers, and it includes those fractions, those wonky numbers like 3 4/5 or whatever. So if x is greater than 2, it does not equal 2. So we want to keep it open. We're going to do an open circle because it does not equal. We're saying, hey, it can't be 2, but it can be 2.000001, right? So it can be everything greater than 2. Now, what I was saying about writing this correctly and seeing that arrow here, if it's written correctly, see how my arrow points to the right? That's the direction you're going to be shading, okay? But that only works if it's written like this. If it's written like this, don't do that. So that's the direction we're shading, and we're doing all real numbers, so it's going to be all of those. What about this? X is not greater than or equal to 3, and our domain is integers. Well, when you get a not greater than on this, what you want to do is rewrite this. So it's not greater than or equal to, and in a previous video we talked about this, I just had to double check. X is then less than 3, no equal sign because that's not included in there. So what we're going to do is say we want all of our integers. So x, I think I said less than. Oh, it says not greater than. Whoops, see, I wrote it wrong. I said less than, but I wrote it the wrong way. So this is x is not greater than 3, which means x is less than 3. So I'm going to say, okay, 3, 4, and then this is 2, 1, 0, -1, -2. But it's only integers. Well, we go back and we look at our little cheat sheet and we remember, okay, our integers are going to be things that are the whole numbers plus their opposites, right? So less than 2, does that include 3? It does not. So it's going to be 2, 1, 0, and -2, and or -1 and -2, just like that. It's not the thing, the gaps in between there, and it doesn't include 3. I wouldn't mark it wrong if you put an open circle on 3 here just to indicate that, but you don't have to. So let's take a look at example number 3 here. All real numbers. So x is greater than or equal to -1, and our domain is all real numbers. So -1 here, and then that's 0, 1, and 2. And this is -2, -3. So it's greater than or equal to -1, so it's included, and it's written correctly, and our arrows point to the right. So we're going to go all real numbers means everything in between there. Those fractions, those decimals, all of that. We're going to shade all of that in. All right, for number 4, it says x is less than -1, and we only want positive integers. So if you take a look at this, you will see that -1, so if I put -1 here, and then this would be 0, 1, and 2, -2, -3, -4. So x is less than -1. So if I were to graph this just normally, right, I would put an open circle here, and it would look like this. However, we only want to include positive integers. There are no positive integers in this domain. So your domain is going to be a null set, which looks like that. That is not a 0, that's just a null. When you put a line through it, it means nope, not, there's nothing there. There's nothing in that integer. All right, x is greater than or equal to -5, and we want to do positive integers. So if we do -5, -4, -3, -2, -1, 0, 1, and 2, and so and then this is -6. So -5 and is equal to, so if we were to graph this normally, we would close our circle here and we would just go all the way this way, but we're only doing positive integers. So that again is those whole numbers. So it's just 1, 2, and I'll put one more here, 3, and then if we had another one, 4, right? It would keep going just like that. So that's what that domain would look like. Okay, so let's take a peek at some more examples here. All right, so for example number 6, we have x plus 2 is less than 0. So the way that we want to deal with this is we want to solve for this first. So we're going to -2, -2, we get x is less than -2, and we want all real numbers. So put -2 here in the middle, -1, 0, 1, 2, and 3. I was always forgetting which, like, how do I remember the orders, how do I remember the numbers are getting larger? If you're right-handed, as you write, the numbers are getting larger. That kind of helps. If you're left-handed, just think opposite. So, and then there's -6. So x is less than -2, but it's not equal to, so open circle. And then everything less than, you see the arrows pointing to the left, all real numbers. We're going to color that whole bad thing in. Bam, there we go. That whole bad boy colored in. Beautiful. All right, so let's look at this example 7 here. We have we've got to get that x by itself, so we're going to add 3 to both sides. When we do that, we get x is greater than or equal to -2, and we're talking all integers. So x is greater than -2, so I'm going to go down here, -2, -3, -4, -5. Oh, wait, what am I doing? -2. Oh, geez, I'm going to write it up here. We're going to say, okay, this is -2, -1, 0, 1, 2, 3, 4, 5. Just after I said, hey, this is how you remember that they go in order. Okay, so in this case, we have x is greater than -2, greater than or equal to -2, so closed circle. This is -3 in that direction, and points to the right, so we're going to shade to the right, all integers. Ooh, integers means just dots along here, just like that. Okay, so that would be our solution there. All right, practice for these guys. Here's A, B, C, and D. Pause the video, practice those, come on back, and we'll do them together. Okay, so looking at this, x is not less than or equal to -2, which means x is greater than -2. So greater than -2, and we want to do positive integers. So -2, -1, 0, 1, 2, 3, 4, 5, 6, just like that, and maybe throw a -3 there. Positive integers that are greater than -2, so that would be 0 is neither negative nor positive, so be careful on that one. But we would just put dots right in here for this. Yours might look a little bit different than mine, but as long as you've got a couple dots in there, that's fine. X is not less than or equal to 4, which means x is greater than 4. We want all real numbers. So I'm going to put 4 here, 5, 6, 7, 8, and then 3, 2, 1. So x is greater than 4, but not including, and it's all real numbers, so it includes all those fractions and all that good stuff. All right. X minus 5 is not less than 0. So we want to add 5 to both sides. But when we do that, we get x, these cancel out, we get x is not less than 5, which means x is greater than or equal to 5. And we want all integers. So 5, 6, 7, 8, 9, 10, 11, 4, and 3. So x is greater than or equal to 5, and we want integers, so we're going to include 5, and we're going to get the rest of these here. All right, x plus 2 is less than 5, so minus 2 from both sides. We end up with, sorry, I didn't leave myself enough room here. X is less than 3, and we want all integers. So we've got 3, 2, 1, 0, -1, -2, -3, and this is 3, 4, 5. So it's less than 3 and it's integers. It does not include 3, but it does include 2, 1, 0. Those are all integers, -1, -2, -3. Okay, hopefully that helps. If you have any questions, leave those below. Otherwise, we will see you next time.